In the name of God, for the second lectures in swarm optimization category, we are talking about particle swarm optimization or PSO algorithm. In Persian, we say بهینه‌سازی ازدحام ذرات. The God told us in the Holy Quran, إن في خلق السماوات والأرض واختلف الليل والنهار والفلك التي تجري في البحر بما ينفع الناس وما أنزل الله من السماء من ماء فأحيا به الأرض بعد موتها وبعث فيها من كل دابة وتصريف الريح والسحاب المسخر بين السماء والأرض لا آية لقوم يعقلون. God tell us, when you say all the environment, all the nature, you may have see some signs, some notes, some signals to understand. If you think and study about them, then you may learn a lot of things. To understand this category, I don't know how Persian English version. Yeah, it's an English version, no problem. To understand in this sample, and the concept behind this PSO algorithm, suppose you are a student, where you want to get progress and improvement in your education, in your study. For example, you are a bachelor student and you want to improve your performance and be a good student. In the same time, there is one good student in your class. Then you have to choice to make a decision. The first one is that you use the way that good student or number one student in your class obey and study how he study and do a way like him, or in summary, follow guidelines, works, ways he doing studying. Then you do that. This is one way. The another option, you say, yeah, I'm also a good student, so I have some experience, so I'm using my own experience. Then I will try to improve the performance and the quality of my learning and education. If you select worst one, then you use the number one student's experience. If you use your own experience, then you follow your experiences. In the nature, there is some algorithms is based on the using the number one student experience and your own student, your own experience, and combine both of them to have a general knowledge about the problem, about how they can solve the problem. Therefore, in algorithm like PSO, it's inspired from the nature and the social behavior and dynamic movement with communication of insects, birds, and the fish. In the sky, you see the birds fly in order and follow the direct path from the north to east and the east to north in the spring and the end of summer, beginning of the winter. Or under the sea, the fishes moves by each other and from one side of the sea to another of the sea for finding the source of the food. Also, there is a lot of other similar concepts in the nature. So if you maybe this figure help us for discussing the idea behind particle swarm optimization. And then I will come back in detail the general idea of PSO. Suppose now you are in position xi, and this is your direction. Then you prefer to continue on this path. Then in the future time, in the next time, you will be here. So xi plus 1 will be here, this point. But based on your experience, this path is better than this direction. Therefore, because you want to consider your best performance or personal best performance, then you change your direction from this side. So instead of going to in this way, you change your direction a bit, move from this side, because this is your experience, your best personal performance. Also, because you are in collection of insects, birds, and the fishes, there is a global performance or best performance of the group, or social behavior of the other birds, other animals in the group. So you have the global best performance of the group, or group best performance. So because you want to consider in the same time your own personal experience and the group experience, then you change the direction a bit from this side. Therefore, instead of to being here, you position at the xi plus 1 is this point. So not this point, not this point, not this point. So you change your direction and the speed according to the your previous experience about finding the source of the foods and everything, and the performance of the groups. Therefore, the PSO, or particle swarm algorithm, was developed by two scientists, James Kennedy and Russell Eberhardt, in 1995. It combines the self-experience with the social experience. So for example, if you use the birds as the one samples, each bird in the sky when they're flying try to combine self-experience and the group experience. The group experience could be the direction and the speed of movement of the first bird in the week when they travel in the sky. You see the shape of V in the sky. So in the shape of sky, the first one is the best one. The first bird move in the front of the others. So it is the global best position. So it's the social experience and also combined with the self experience. By this way, the algorithm try to combine local information and the global information and find the best path for direction, best source of the food for traveling. So it is inspired from the nature, like fishes, like birds, like insects, and the other animals. If you study, there is many samples in the sky collection of the birds, animal, fishes communicate with each other and follow some paths and directions to finding a good source. So this is in this algorithm we uses the number of agents or particles that constitute a swarm. So there is a lot of agents or particles that make a collection or swarm moving around in the search space looking for the best solution. So these items, this swarm of particles moving in the search space looking for best solution. Each particle in search space adjusts its flying according to its own flying experience as well as the flying experience of other particles. So each particle in the search space adjusted تطبيق its flying according to its own flying experience as well as flying experience of other particles in the sky. So here we have collection of flying particles, swarm, and these particles try to change the solutions by communicating with each other. So there is search space or possible solutions and the movement toward a promising area to get the global optimum. So everyone have movement toward a promising area. So if you want to find a good area, best area to find a global optimum solution. Each particle keep tracks its best solution, personalized best, and the best value of any particles, global best or G best. So each particles keep track of personal best and global best. By combining these two parameters with each other, they try to find a good solution, optimal solution in the search area. So each particle adjusts its traveling speed dynamically corresponding to the flying experiences of itself and its colleague. Each particle modifies its position according to the current position. As I told you, the current position, its current velocity, the distance between the current position and personal best, the distance between the current position and the global best. So if you see in this figure, the particle try to move instead of to this direction and reach to this point, change the direction based on the personal best performance and the global best performance at the time of I. So considered this is one problem we want to solve it, and the initial we set the position of each particles randomly. Then every particle have its own direction of its own path and want to travel and to reach to the find the best position. Therefore, the neighborhoods, the sample and items in the one region try to collaborate and help each other to find the best solution. Then each particle have own experience and its global experience. So it's finally try to find a global optimal solution. So in this algorithm, at first we create a collection of particles like this one, uniformly distributed over X. If it be possible, we can uniformly distribute it with a good idea. So then evaluate each particle position according to the objective function. So evaluate position of each item according to the objective function. In optimization problem, we have objective functions. If the particle current position is better than its previous best position, update it. If the particle's current position is better than its previous best position, then modify it, update it. Determine the best position at the best particle according to particle previous best position. So, at the beginning, for each particle's initial particle, and then we have two main loops, one main loop and another loop. For each particle, calculate the fitness value according to the fitness function. If the fitness value is better than the personal best, set the current value as the new P best. So update P best. Choose the particle with the best fitness value as a global best. For each particle, calculate particle velocity according to equation A and update particle position according to equation B. The main loop iterates while maximum iteration or minimum error criterion is not attained. So therefore, for each particle, we initialize particles, then evaluate each fitness of each particles, modify velocity based on the previous p-best and the global best. Check determination criteria. If okay, then stop unless iterate the next iteration. So every time the velocity of each item is updated based on the previous velocity, plus personal best minus current position, and multiple by C1 and the random number plus C2 and random and global best. So therefore, when we update, every time we update, we iterate this process many times, and then velocity of particle updated based on this formula. Then the position of xi updated by a position of previous position. The C1 and the C2 is the learning factor, and the W is interior weights, the amount of effect of the current position. So in this algorithm, particles' velocity on each dimension are clamped to the maximum velocity Vmax. If the sum of acceleration would cause the velocity so that dimension to exceed Vmax, which is the parameter specified by the user, then the velocity on that dimension is limited to the Vmax. Number of particles, swarm size, usually between 10 and 50. So at the beginning, you must create the particles. The number of particles could be usually between 10 and 20. C1, importance of best personal, weight of local information. C2, importance of neighborhood best, weight of the global position, a limit of velocity, and the random variables. So usually C1 plus C2 is equal to 4. So you can could be 2 and 2, 1, 3, 3, 1, and a different combination. If the velocity is too low, then algorithm too slow. If the velocity is too high, then algorithm too unstable. Then particles update rules. V equal to previous V. The velocity is equal to previous one. Multiple C1 random. Then personal best plus C2 random global best. And P equal to P plus V. P particles positions, V path direction, move direction, and velocity. C1 weight and the local information, C2 weight of the global information. And the P best is the best position of particle, and G best is the best position of software or swarm or population. So this is the same formula as I told you previously. So in interior, this is the first part, term is interior, make the particle move the same direction and with the same velocity. So in this, the first part. The second one is a personal influence, this part, as you see. Improve the individuals, make the particle return to the previous position better than the current position. This is conservatives, and try to consider its own experience and follow that. This is also make the social influence, make the particle flow the best neighborhood directions. Then we have two combination of intensification and diversification. The velocity, previous velocity is diversification. Explore the previous solution, find the best solution of the given region. And these two parameters, intensification inside from intensification to the personal based and the global based, or moving the items or moving the particles to personal best site or global best site, so it is intensification. Explorer, the previous solution, finds the best solution of the given region. So this is intensification or intensify, focus on the same region as the previous. Another one is diversification. Search new solutions, find the region with the potentially the best solution. So I want to try to check new solution, new paths, new directions. So this is help to diversify the solution. By this way, try to search new part of the search spaces and try to find new solution. As I told you in previous lectures, in the most cases, we try to balance between intensification and diversification. In most cases, at the first of algorithm running, the rate of diversification is high, and then intensification will be high in the last iterations. So check out this solution. We have some particles here. It moves based on the one direction. The goal is here. We want to every samples to move to find this global position. Then we check each particles position and which fitness based on the objective function. So every particle's direction will be updated according to its the neighbor and the global solution and the best solution. As you see, these items in this region concentrate in this position, item in this other region concentrate in this position, and then finally all of them move to this position because it is the global best and they help to find the global best solution. So we have this algorithm has its own advantages and disadvantages. Insensitive to scaling of the design, insensitive to scaling of design variables. So if we have many variables, so it is no problem. Then it could be used for solving many large problems, and it is a scalable algorithm. It has simple implementation, easily parallelized for concurrent processing, derivatives free, and very few algorithm parameters, and very efficient global search algorithm. So this is main characteristic of PSO algorithm. It's a very efficient global search algorithms, and also disadvantages: tendency to fast and the premature convergence in the mid-optimal point. So this is one drawback of this algorithm. Also weak local search ability. So also this is another problem of this algorithm, because each algorithm has its own advantages and disadvantages. We must study and understand all of them and then select best one for solving the solution. So also there is a lots of different approach, different type of PSO algorithm. You see some of them here. Then based on the algorithm problem you have, make you select one of these type of algorithms.